Hi, welcome to RAR Math. Today I'm doing a series of videos on functions and parent functions and their graphs. In this video, I am doing the square root function, the reciprocal or rational function, and then one example of the square root function. So for the square root function, with a lot of these that I've been doing, if you've watched any of my other videos, I'm starting with a table of values. And a lot of times with a table of values, when you're graphing, you'll start with something like -2, -1. The problem is the square root of -2 does not exist because the domain of the square root of x is x has to be greater than or equal to 0. Because the domain says that x has to be greater than or equal to 0, we may as well start at 0, and the square root of 0 is 0. 1 and the square root of 1 is 1. 2 and the square root of 2 is 1.414. You don't have to know that, and I'll probably skip up to 4, and the square root of 4 is 2. I like using the pretty numbers when I graph. You don't have to use the decimal numbers. So we have 0, 0, 1, 1, 4, 1, 2, 3, 4, 2. And this looks a lot like a parabola that has fallen over. And that's what the square root parent function looks like. The reciprocal function, I'm not really going to use a table of values. This is a kind of funky function. The domain of this one says that x cannot equal 0. If you want to get into interval notation, it's -infinity to 0, joined with 0 to positive infinity. We cannot equal 0. It becomes an asymptote, a barrier that the graph cannot cross. And the reason that it's important to know it's an asymptote is this graph approaches the x and y axes without ever crossing them. They're like walls that you forever get closer to without touching. And so that's what an asymptote is. An asymptote is a barrier that a graph approaches without ever crossing. And so this graph has an asymptote at both the x-axis and the y-axis. For this graph, this is a transformation. I have a whole series of videos on transformations you can look up, but the domain here says that x plus 2 cannot has to be greater than or equal to 0. So x has to be greater than or equal to -2. So if I were doing a table of values, I'd start at -2. -1, 0. The square root of -2 plus 2 is the square root of 0. The square root of -1 plus 2 is the square root of 1, which is 1. The square root of 0 plus 2 is the square root of 2. So it looks like we're mirroring this, which makes me think I should jump up to 2. The square root of 2 plus 2 is the square root of 4, which is 2. So 1, 2, 1, 2. And so this plus 2 just moved. This plus 2 just moved the graph back 2 places. All right. I hope you enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.